In our last class, we discussed the Nernst equation and the application of it. The application was that with its help we can find out the cell potential. Second was we can determine the cell potential of the concentration cell. And one more application of it is that we can find out the concentration of the solution by knowing the concentration of one of the electrolytic solution and the electrode potential of the electrochemical cells of the which are used in the determining of the electrode potential or the EMF of the cell. Right, now one by one we will discuss the numericals related to the Nernst equation. So just see the first numerical. It is based on the EMF of the cell and the electrode potential and the concentration of the electrochemical in the electrochemical cell, the electrolyte used. Right, now just have a look over here. Now in this numerical we have to calculate the standard electrode potential of nickel ion, right, electrode, if the cell potential of the cell, right, it is given Ni half cell Ni2 positive, molar concentration, that is the concentration is given to us of the nickel ion in the aqueous solution, salt bridge, copper ion, its concentration is given to us, half cell copper is 0.59 mole. Now what is 0.59? It is the standard electrode potential of nickel ion we have to calculate, and the cell potential is given to us. Now 0.59 is the cell potential. It is given E cell. It is given to us 0.59 volt. Right. Now in the question it is also given the standard electrode potential of copper electrode. It is 0.34 volt. Now first of all we will just write down the cell representation. Right, Ni half cell Ni2 positive, salt bridge, copper ion, half cell copper. Then what is given to us? The concentration of nickel ion is given to us 0.01 m, and the concentration of copper ion is given 0.1 m. Now we will write down the cell reaction here just to see whether the equation is balanced or not. So it is Ni plus copper ion Cu2 positive gives Ni2 positive plus copper. What can you see from here? That the nickel is losing 2 electrons and changing into Ni2 positive, and copper ion is accepting the 2 electrons and it is changing to copper. Right. Now here the coefficient is unitary, that it is 1 unit in each of the species. Right. Now we will write down the Nernst equation for determining the for determination of the EMF of the cell. It is E cell equals to E naught cell minus 0.059 upon n log, here Ni2 positive is the product. So we will write down log product ion upon the reactant ion. Again I am repeating here, log it will be product ion which is present here, right, after the oxidation, and this is the reactant, right, this is the Cu2 positive ion. Right. Now we will just put the values which we know. E cell we know it is 0.59 equals to E naught cell we don't know. We will write out E naught cell minus 0.059 upon 2. In place of n we are writing here 2 because there is an exchange of 2 electrons here. Ni is losing 2 electrons and copper is accepting 2 electrons. So here n equals to 2. Log, what is the concentration of nickel ion? It is 0.01 m. This is we have written here 0.01 m. Copper ion is 0.1 m. We have written here. So 0.59 equals to E naught cell minus 0.0. On dividing 0.059 by 2, we will get 0.0295. Log, thus we are writing in an exponential form 10 raised to power minus 2 upon 10 raised to power minus 1. So what we are getting here 0.59 equals to E naught cell minus 0.0295 log 10 raised to power minus 1. And you know that in logarithm, anything which is raised to the log 10 raised to power, it will come in front of it. So it is minus 1 which is coming here. So it is getting 0.59 equals to E naught cell minus, this is minus 1 here, minus 1, 0.0295 log 10. What is the value of log 10? It is 1. So here it is 1, right? So it is 0.59 equals to E naught cell minus minus plus 0.0295. So here log 10 value equals to 1. right? So it is now we are getting the value for E naught cell equals to 0.59 minus 0.0295. What is the value of E naught cell? It is 0.5605. This we are getting the standard EMF of the cell. Now, what is the formula for the standard EMF of the cell? It is E naught reduced minus E naught oxidized. Now, E naught cell value we have calculated here. We are writing it here equals to E naught reduced. Now, in this cell representation, which is undergoing the reduction, yes, it is the copper electrode which is undergoing the reduction. So, its electrode potential, standard electrode potential is 0.34 minus E naught oxidized. This is there. Now this E naught oxidized is actually a nickel electrode equals to 0.34 minus 0.505605. So on subtracting we will get minus 0.2205 volt. Now this is the electrode potential for the nickel electrode. Now students, just look at the next numerical. Here a voltaic cell is set up at 25 degrees Celsius with following half cell. Aluminum ion concentration is given to us. It is 0.001 m and nickel ion is 0.50 m. Now we have to write an equation for the reaction that occurs when the cell generates an electric current and determine the cell potential, that is E cell. Now what is given to us? The standard electrode potential of nickel electrode and that of aluminum electrode is given to us. Now the first part of the question is that we have to write an equation for the reaction that will take place when the electricity or electric current is derived from the cell. So here we have to first predict that which electrode will undergo the oxidation and which will undergo the reduction. Now this we can do just by comparing the value of standard electrode potential which is given to us. Now from if you compare the value of nickel electrode and that of aluminum electrode, you can see that which one has got more lower electrode potential, standard electrode potential. It is minus 1.66 volt. So as we have done in the application of electrochemical series, that the standard electrode potential will be as much when it is as low compared to the other electrode, that the electrode which has got lower electrode potential will undergo the oxidation. So here the aluminium electrode has got more negative or more lower value of electrode potential, so it will undergo the oxidation. So here aluminium undergoes the oxidation. So we will consider it to be oxidation half cell reaction. Now the nickel electrode, since it's compared to the aluminium, has got greater value of the standard electrode potential, it will undergo the reduction. So you can see from the reaction that which I have written here that the aluminum electrode is undergoing the oxidation and the nickel electrode is undergoing the reduction. Now here aluminium, it loses 3 electrons to form aluminium ion, and nickel ion Ni2 positive accept the 2 electrons to get changed into nickel. Now here there is an unequal exchange of electron. That means there is 3 electrons which are given up, but here it is only 2 electrons which is accepted. Now to just balance, we will just cross multiply the equation first by 2 and second by 3, right? So that the exchange of number of electrons becomes equal and it gets cancelled out. Now here this complete equation is being multiplied by 2, right? This is multiplied by 3. So it will become now 2Al. The net cell reaction is 2Al plus this is 3 Ni2 positive gives 2Al3 positive plus 3 Ni. And how many electrons are being exchanged here? N equal to total electrons is N equal to 6. So now next step will be to determine the cell potential. For that we will write down the formula for the Nernst equation. E cell equal to E naught cell minus 0.059 upon N log. Here students, we will write down the product ion, right? That is aluminium ion Al3 positive. You can just see that it has been raised to the power of the coefficient. So here it is 2. This is the coefficient 2. Upon the reactant ion, it is the Ni2 positive. The coefficient here is 3. So it is whole cube. Now for this we have to find out the E naught cell. You can do it earlier before also and you can do later also here. So E naught cell equals to E naught reduced minus E naught oxidized. That is the electrode potential which is for the reduction one and this is for the oxidation. So Ni2 positive, how much electrode potential is given? Minus 0.25 volt. We put here, minus aluminum ion, it is minus 1.66 volt. So on solving we get 1.41 volt. This is the standard EMF of the cell. So E cell equals to, we will put here standard EMF, that is 1.41 here, minus 0.059 upon 6. N is here 6 log 10 is to power minus 3. The molar concentration of aluminium ion is given 10 is to power minus 3 in the question. Raised to the power square upon 0.50 raised to power cube. Right? On solving it, 1.41 minus 0.059 upon 6 log. Solving this part, we get 8 into 10 is to power minus 6. Now student, this is log 8 into 10 is to power minus 6. Now in logarithm, the multiplication becomes addition. We are going to add them up. So 1.41 minus 0.059 upon 6 log 8. For this into we'll put here plus. This is 10 raised to power minus 6. So minus 6, it is an exponential. It will just come before. So it's minus 6 log 10 here. Now you know that log 10 value is 1. Right? So it is E cell equals to 1.41 minus 0.059 upon 6, 0.9031. It is the log 8 value. Right? In the logarithm table, we will find out the value log 8. Here it is plus minus 6, log 10 1. So minus 6 into 1, it will become minus 6. Now here it's 0.9031. So we have done here after decimal 4 places are there. So 6.0000. Now equals to 1.41 minus 0.059 upon 6. On solving this, we will get minus 5.0969. Either you just get it multiplied first, right? Or just cancel it and then you multiply. Right, so here we are doing first multiplication right here. So 0.3012 upon 6 is 1.41 plus 0.0502. On solving this, we will get 1.4602, which is approximately 1.46 volt. So here the cell potential is 1.46 volt. So students, in this type of question, the electrode potential will be given to us, right? We are not given any cell reaction here, right? Only the concentration term is given to, concentration term of the ions are given to us and the electrode potentials are given to us. So just by comparing, we will just first write down the oxidation half cell reaction and the reduction half cell reactions, right? And then we will write down the net cell reaction. And then after that, we can solve this equation, solve this for E cell by writing down the Nernst equation.